Hello, and welcome to this video on how physicists have found experimental evidence of lifeless particles behaving in a lifelike manner. If you have been watching this channel for a time now, you may remember a previous video on a physicist's theory about the origin of life. This theory has recently gained experimental support in findings published in Physics Review letters. The original theory postulated that as energy is introduced into a system, the fundamental elements interact in a more complex way. This increasingly complex interaction acts out the laws of thermodynamics by diffusing energy into the surrounding environment. This satisfies the requirement for an increasing entropy in the universe. The authors of this new paper describe the problem as, however, non-equilibrium systems often never reach a steady state, and constantly switching behavior. In biological systems, switching is a common theme in the regulation of the cell cycle, gene expression, and neural activity. They designed this experiment to increase the energy in an environment using lasers. This interacted with melamine formaldehyde particles in an environment of argon gas plasma. Since each particle's oscillation frequency was slightly different due to variations in the particle mass, and some began to move out of phase with the rest of the sample, the amplitude of vertical oscillations were increased. This created nonlinear interactions and led to nucleation, or melting in the sample. This is where energy is rapidly redistributed into the horizontal degree of freedom. This redistribution of kinetic energy spreads across, at the speed of sound in a crystalline lattice, and moved at roughly 1 centimeter a second. It is similar to the phenomenon observed in other vibrating granular layers, and this created a flat crystalline layer in effect. The molecules involved with this continue to switch between liquid and crystal states, the same switching seen in lifelike molecules. This is similar to the process involved with neurons and other basic biological activity. Using a simple cell wall as an example, cell surface proteins, and in particular protein channels, act as gates. As a result, they need to open and shut selectively. This allows things to pass into and out of the cell. This can be done in a number of ways, one of which is pH dependent. An article by Russo and Company in 2012 describes this. Here, a protein gate underwent a conformational change in response to pH and one amino acid's isoelectric point. In the context of the author's explanation, there are methylation structures. These have been previously described, but in short, they bind with sections of DNA, and these sections block gene expression through a rigid structure, unlike the usually more fluid and mobile DNA structures. Although not necessarily associated with the crystallization of DNA, it shows how in a more complex environment and way, the cell has developed and effectively evolved mechanisms taking advantage of this physical property. You will find the links to the article below in the description box. Thank you for watching. Please post any comments, questions, or suggestions you may have below.